Hi, it's Bill. We're going to finish up the jig that we worked on for our horizontal bandsaw, and all we need to do at this point is mount the bolt, make a little plate, and thread that plate to hold the jig in place on the table while we use the jig. We found that the vise kind of kicks it out a little bit, so we're going to put a little bolted connection in there, and it's going to grab the slot right in the table, and that's going to lock the jig in position. I think we're also going to put some holes on the front of the jig to aid in holding the material down because the vise is kind of far away from the blade. Okay, so we've got the jig in the saw, and our plan, drilled our bolt last time. We're going to drop this bolt through the slot in the table that the vise goes in, and we're going to cut. We got some cold rolled quarter-inch plate here. We're going to cut a little tab, and we're going to thread that. And that's going to catch on the bottom of the table. What that's going to do is that's going to keep the jig in position. We're still going to be able to use the vise because that bolt is further behind. It's not going to interfere with the nuts or anything on the vise, and the material is still going to be able to go in here. But what we're going to have to do is make sure that this doesn't move. And the other thing we're going to do is we're going to see if we can fit a hole here and here on this jig. We've got some clamps that go on our welding table that we might be able to squeeze one in here. They basically drop into the hole and they cam over when you tighten them up. I'll show you that in a minute, but I'm thinking that if I put one here, it's going to help hold shorter pieces of material when we make a cut. Right now, you've got a pretty long distance that you need to cut anything before you need to clamp it in the vise. So by having something closer to the blade, I'm hoping that we can cut a little shorter material. The problem is that because we're at such a steep angle, whatever we put in there, we have to think about the placement of that hole to make sure that we don't have an interference with the blade and the clamp. The other thing I didn't touch on a lot on the other first part was what we had the welder set at. I think I said it was 200 inches per minute. This is an old Millimatic 200. This is what I used. The 200 inches per minute, again, we just pull the trigger, wait for 6 seconds, and then measure that wire length at a 0, and that gets you a quick way to get inches per minute. And as far as what voltage on this welder, we're set on the low range right now, and we start out at 10 volts on one, and each increment is 2 volts. So we were welding at 4, so that's 10, 12, 14, 16, so we're at 16 volts, 200 inches per minute. We're using 30 thousandths inch wire, I think I mentioned that, and then we also have, we're using an argon CO2 mix 7525. Okay, so we're going to lay out the tab to hold the threaded bolt. I measured the slot and wrote down those dimensions there, and we're going to use a scribe and lay this out on the plate. I'm going to cut this out on the bandsaw, a vertical bandsaw. I didn't get that on video. I'm just using scribe because we put a little bit of lubricant when we use that saw, and it tends to wash marks off. We're just going to find the center of that rectangle and punch that in preparation for tapping in a moment. Just center punching that there. And then what I like to do is compare it to a nut so you can be assured that you've got enough material to thread. Okay, so here we are. We're going to go ahead and we'll give that punch a little more so it's easier to locate the drill. And we're going to go ahead and drill this with the 5/16, and we're threading it 3/8 by 16 coarse thread. And we're just going to go ahead and drill that on the drill press. So we're drilling this out the rest of the way. Once we get done with that, we're going to go ahead and countersink on both sides, just make it easier to start the tab, make a cleaner hole, get rid of that burr, and then just flip it over and just kind of hit it real lightly on the bottom side. Okay, so we're getting ready to tap this thing, and one thing you got to check your taps. I didn't on this one. You're going to see in a minute that's it's going to cause a little bit of a problem. I just went ahead and didn't even bother looking at it. Made sure it was the right size, but I'm using a little tap guide there, and we're having some difficulty in shouldn't have difficulty, but this is why. That tap is just ready for the trash can, missing teeth and just really worn out. So check that before you start. I should have done that, and caused me a little delay. That tap should look like that, a newer tap anyhow, and it should thread like this, nice and easy, and the tap guide keeps things nice and perpendicular. Some of the taps have a little hole in the back. You can kind of use them in the drill press to kind of guide it with the countersink, but this one didn't have that. So we're just going to go ahead and check it with a bolt, make sure that everything is clean and that it fits okay, and it does. It fits pretty good. So the next thing we're going to do is go ahead and cut that piece out. Okay, so yeah, we cut it out on our vertical bandsaw, and we're just going to clean up the burrs on the edges, and then we're going to go ahead and move over to our disc sander and go ahead and round the corners and just make it a little nicer. Do that real quick on all four corners, and then we're ready to fit this in the bandsaw and check it out. So now we've got the jig in the bandsaw. Lowered that plate through the slot, tighten it up, and kind of check it for fit, and it looks like it's going to hold it pretty good. Tighten it up. Its vise locks up now nice on it. Swivel the head over a little bit and get our final angle adjustment, and then we'll be ready to chop that end off. And we're going to have to do that on the vertical as well because it's going to hit the guide. One of the things we wanted to do is use some of our existing clamps to be able to clamp smaller material, so I'm just kind of figuring out where I can put a clamp and minimize the likelihood of it getting chopped off with the blade. So I kind of come up with a location that's going to give us a little bit of flexibility in cutting shorter pieces, mark it, and then. So I'm just going to go double check that clamp measurement, mess around with the caliper a little bit, and it's a bit under 5/8, so we're going to go ahead and drill a 5/8 hole in the top of the jig. And here we are at the drill press, going to drill again, drill a pilot hole in that, and then go ahead and open it up with the 5/8. Now I wish we had a reamer, but we don't, so I do have a 5/8 drill. I had two of them there. I went ahead and picked the sharpest one, and we'll go with that. And one thing I didn't do is didn't lower the table enough for clearance. So again, a little oversight. I have to realign the part. I don't like always doing that, but sometimes you can table if you forget and you have no choice. Went ahead and drilled it with the 5/8. And then the next thing we're going to do is go ahead and take it over to the bandsaw and chop that long end off. Okay, so here we are at the vertical bandsaw. I'm just going to do a rough line. The front piece of the jig hit the guide on the horizontal, otherwise I would just cut it off in one shot. So we're just going to go ahead and freehand this. We're just making clearance to keep the front of it from hitting the front guide on the horizontal bandsaw. So once we got this cut, we're going to go ahead and take it over to the horizontal bandsaw and cut it at the angle. So here we got it set up. I got a scribe line set on there. I just want to see how close we are to our target angle, which in this case is going to be 60 degrees on the cut. So go ahead and chop that off, and that's going to allow us to sight the blade a lot easier when we go to cut our material. You're going to have a pretty good indication where that blade's going to end up on your part without having to look down on top of the blade sometimes, which is kind of hard if you're really trying to get right on the line. It's hard to get a good angle on it, and just going to cut this off the rest of the way, and then we'll be ready to actually put some material in there and try this thing out. Okay, so I found some material. We're going to cut it real quick to length. What I'm going to do is cut 3 pieces and make a little triangle real quick. And it's not the cleanest material, but it's what we had. So we're just going to chop it down rough, and then we're going to tack weld one end of it to keep them together, and then put it back in the jig. We've got our line set up. We're going to use our new clamp, and the clamp is going to lock that material in, and we're going to go ahead and cut all 3 at once and flip it and do the same thing on the other side, and that's going to ensure that we have 3 pieces that are identical in length. and hopefully the angle will be the same on all of them. So we're just going to go ahead and cut the one side, flip it, and cut the other. And now one thing I did, we use this bandsaw's got that lubricant in there, and it works good. It keeps the material cool, and it gives you a nice clean cut. But one of the things I'm finding is that stuff is really hard to get out of the material when you go to weld it. And in a moment, when I go to put this thing together, I thought I got all that stuff out of there, but I think it stays in the corners of the tube, and then when you start welding it, it starts causing you problems. So I'm going to have to think of some other ways to get that stuff out of there. Okay, so we're just going to go ahead and clean these up real light with a file and deburring tool. I want to see how they fit, so I'm not going to hit them with a grinder or sander or anything like that, because I want to see how they fit coming out of the saw, just to see how close we were on the angle and what kind of consistency we're getting with it as we use the clamp and we take the material in and out of the jig. So we're just going to go ahead and clean it up on the inside and clean up the outside, make sure there's no burrs on it. Again, that saw does a pretty good job. And I'll go ahead and do just a real rough fit up, and you know, it looks real good. You may not be able to see it real well here, but I have some other views in a second. But it fit real well. I'm real pleased with it for what we're doing here. It's going to work fine. Just go ahead and clean up a little bit more on the burrs there. There was some on the ends, and again, the fit is really good. And we're going to go ahead and check some of them with our angled guide, and it's right on the money. So now we're just going to get it cleaned up, and what we're going to do is we're going to just fusion weld it with a TIG welder and stuff. So I'm going to go ahead and clean up the outside a little bit more. It's all rusty and everything, and just try and get a better weld. Again, that cutting fluid that gets in the corner there, and even though I wiped it out of the end, I think it just kind of migrates down that corner in there. So I'm going to have to work a little bit at getting that stuff out completely. Maybe even heat it with a little bit with the propane torch before I. Okay, so the parts are clean. We got it in our welding table to kind of, and we're just going to put some fusion tacks on each side. So once we finish cleaning the same, we're going to get the opposing side, and then go ahead and weld it up. The fit was real good. There was a little bit of a gap in some of the parts, which made it a little bit hard to get a good tack, but it wasn't any problem. I think that blade, because it's stretched out so far when you make those angled cuts, your cuts have a bit of a taper to them, and I don't think there's anything we really can do with that. I might check the blade guides and make sure that they're good and tight, but it's just one of those things where you have that much blade out, it's going to taper a little bit on you. So it wasn't too much of a problem, but was a problem is that cutting fluid. Usually I've done stuff before like this and not had that much of a problem. And this time I guess I just didn't get all of it out, and it started bubbling out of there when you're trying to weld it. And in a moment you're going to see that a bit. I'm going to have to come in with some filler rod and kind of fill in some areas that really had a lot of porosity from that stuff boiling off and getting into the weld. So again, if you TIG welding stuff, it's got to be really clean. There's no way around it. You got to make sure it's really clean, not only from rust and things like that, but also fluids or anything like that, oils. So here we are. I've got a little bit of a arc shot here. Again, using just a little bit of filler rod, again in the areas that, and at the tip here, because that tends to melt away. And just make sure that we, yeah, you can see a little bit of porosity there, and we're just going to kind of go over that with some welding rod. Just kind of try and boil that stuff out and kind of chase it out. Well, here's the finished part. Kind of ran out of time at the shop, but we just went outside and hit it real quick with the flat disc on both sides, and it turned out pretty good. I think the jig is going to help a lot. You know, there's a lot of fit up and other things that go into doing something like this, but try and get a little better view of the corners and stuff. But the jig itself, I think, was right on the money. It gave us good repeatability, and I think we're going to get some use out of it. So Thanks for watching, and take it easy.